Hi everybody. Welcome to an example of teacher-centered instruction as a part of Task 2 in the Improving Secondary Instructional Practices Through Technology Integration and Constructive Techniques Professional Development. This lesson is a teacher-centered lesson, which means that the teacher or the instructor is the primary or only source of knowledge for the instruction. I'll go through this lesson as if you are my students and I am your teacher. We'll talk about some prior knowledge that stems from previous discussions that we've had or previous lessons, and then we'll go into definitions of the angles that are created when two lines are intersected by a transversal. We'll also go through the three theorems and the postulate that are used to examine the relationships that are created when the two parallel lines are intersected by a transversal. So here's the beginning of the lesson, so get out your pencils and your notes and sit quietly, please. First angles we need to talk about are angle relationships that we discussed in previous discussions, or that we had in previous chapters. The first type of angles are vertical angles. So vertical angles result when two lines intersect. Whenever two lines intersect, four angles are created, and those four angles can be divided up into two pairs of vertical angles. So vertical angles are two congruent angles that are formed by intersecting lines. Vertical angles are on opposite sides of the intersection. So angles 1 and 2 here, these are vertical angles. They're across the intersection from each other. The top and bottom angles are also vertical angles. They're just not labeled. Another special type of angle is a linear pair. A linear pair is a set of two adjacent angles that form a straight line, which results in the two angles being supplementary. So anytime you have two angles that are next to each other that form a straight line, they are a linear pair. So this linear pair can be created any number of ways. One way, which I have here, is I have a straight line and I have an endpoint and a ray going off in one direction. That creates a linear pair. Over here we have two lines intersecting, which actually creates another linear pair. Two in this unmarked angle are a linear pair. One in an unmarked angle are a linear pair. Adjacent angles that form a straight line make a linear pair. Linear pairs are supplementary, which means they add up to 180. So back over to this example, if 3 has a measure of 120 degrees, then 4 has to have a measure of 60 degrees because they are supplementary, which means they add up to 180. If they don't add up to 180, they're not supplementary and they're not a linear pair. If two parallel lines are cut by a transversal. So here we have two parallel lines. We have the two yellow lines are parallel. We know they are parallel because they have these little arrow markings on them. You may have seen them before. Any lines that have one arrow marking on each are parallel to each other. You might see another set of parallel lines that have two arrows on them, which means that those two lines are equal to each other. We might go into multiple sets of parallel lines in a given picture, and I'll make sure that we point those out as they come up. But right now we're just going to focus on two parallel lines cut by one transversal. So the yellow lines are the parallel lines. The gray line is the transversal. On the top of the picture, where the gray line intersects the top yellow line, four angles are created. On the bottom of the picture, where the gray line intersects the yellow line, four angles are created. So as a whole, when one transversal intersects two parallel lines, there are 8 different angles that are created. Now, a lot of congruence relationships are created as a result of the transversal intersecting the two parallel lines. Most of these congruency relationships only exist if the lines are actually parallel. So all of our theorems and postulates that we're going to discuss start with if two lines are parallel, or if two parallel lines are cut by a transversal. So the two lines have to be parallel to apply any of the following postulates and theorems. You may notice that there are some vertical angles and there are some linear pairs. So that's actually where we're going to start. So if two parallel lines are cut by a transversal, then which angles are congruent? Well, we'll get started with vertical angles. The vertical angles are color coordinated. 1 and 3 are both green. They are vertical angles. And you may remember from 2 slides ago, vertical angles are congruent. 2 and 4 are vertical angles. They are also congruent. 6 and 8 vertical angles. 5 and 7 vertical angles. So we have 4 sets of vertical angles in this picture. This statement right here reads angle 1. This little marking right here means angle. Angle 1 is congruent to angle 3. What does congruent mean? Congruent means that the angles have the exact same measure. For all intents and purposes, they are exactly the same angle, just rotated or translated or slid to a different location. So 1 and 3 are basically the same angle, or they are the same angle. They're just in a different location in the picture. So if angle 1 has a measure of 60 degrees, then so does angle 3, because they're congruent. So 1 and 3 are congruent, 2 and 4, 6 and 8, and 5 and 7. The other special angles, or pairs of angles that are created, are linear pairs. Linear pairs are angles that are adjacent to one another. 2 and 3 are adjacent. They make a straight line, the gray line. They are a linear pair, which means they have to 180. 1 and 2 are adjacent. They make a straight line, this yellow line, which means they have to 180. There are 8 sets of linear pairs in this picture. 1 and 2, 2 and 3, 3 with 4, 4 with 1. 5 and 6, 6 with 7, 7 with 8, 8 with 5. There are 8 sets of linear pairs, like I said, and every set of linear pairs adds up to 180. Seems to be a lot of redundancy in these pictures, and that pattern will persist as we go through this discussion. The first if-then statement we're going to look at is the corresponding angles postulate. Before we go on and talk about the other 3 theorems, we have to start with a postulate. You might be wondering, well, what's a postulate? Well, a postulate is a statement that is assumed to be true, that every mathematician has agreed on is true. If we didn't agree on this statement being true, then we'd have nowhere to start, and we could not prove the other 3 theorems. A good example of a postulate is what color is the background of this slide? It's blue. How do we know it's blue? Well, it's blue. How do we know it's blue? Because we've all been told it's blue. We've all agreed that this color back here is blue, just like we've all agreed that this color right here is yellow. Those are postulates. We can't prove blue. We can't prove yellow. We can't prove gray. We can't prove green. We're just all assuming that we all assume that the background on the slide is blue. The number 8 is green. The number 5 is gray. The number 7 is yellow. Those are all postulates that we've all agreed to be true. So the corresponding angles postulate is just a statement that we all agree to be true, because it gives us a starting point for examining 2 parallel lines cut by a transversal. So what are corresponding angles? Corresponding angles are angles that are in the same location. So if I look at this top intersection, there are 4 angles created. There's the one on the left, number 1, the one on the top, number 2, the one on the right, number 3, the one on the bottom, number 4. The same is true down here. The gray and the yellow line intersecting makes 4 angles. The left one is 5, top is 6, right is 7, bottom is 8. Corresponding angles are angles that are in the same location. I have color coded these angles. 1 and 5 are both on the left. They're corresponding. 2 and 6 are both on top. 3 and 7 are both on the right. 4 and 8 are both on bottom. What the corresponding angles postulate tells us is that angles in the same location are congruent. So if they're in the same relative location as compared to the intersection of the transversal and the parallel lines, then the angles are congruent. So 1 and 5 are congruent, 2 and 6 are congruent, 3 and 7 are congruent, and 4 and 8 are congruent. From there, we can talk about alternate interior angles. Well, alternate interior angles, that theorem itself has 2 new words in it, alternate and interior. Well, let's start with interior. Interior means inside. Those are the angles that are inside, the parallel lines. So what angles are inside the parallel lines? 4 and 5, 3 and 6. They're in between the 2 parallel lines. Alternate means on opposite sides of the transversal. So the angles that are inside the parallel lines on opposite sides of the transversal. So 3 and 5 are on opposite sides of the transversal. 4 and 6 are on opposite sides of the transversal. Thus 3 and 5 are alternate interior angles, and 4 and 6 are alternate interior angles. What this theorem tells us is that if the angles are alternate interior angles, if the lines are parallel and intersected by a transversal, then the alternate interior angles are congruent. So what that means is that 3 is congruent to 5 and 4 is congruent to 6. Now the question you might ask is, how are they congruent? Well, it goes back to the corresponding angles postulate and vertical angles. So let's look at this. 2 and 4 are vertical angles, so we know they're congruent. 6 and 2 are corresponding angles, so we know they're congruent. So since 2 is congruent to 6 and 2 is congruent to 4, we know by transitivity that 4 and 6 are congruent because we can switch them around. Right? Same thing is true with 1 and 3 and 1 and 5. 1's congruent to 5 and 1's congruent to 3. Therefore, 3 is congruent to 5. So that is just kind of a quick proof of the alternate interior angles theorem. The next theorem is the alternate exterior angle theorem. Once again, we get that word alternate. So alternate means on opposite sides of the transversal. So 1 and 7 are on opposite sides of the transversal. 2 and 8 are on opposite sides of the transversal. Exterior means outside. Exterior means outside. So their angles are on opposite sides of the transversal and on the outside of the parallel lines. So 4, 5, and 6, or 3, 4, 5, and 6 are on the inside. 1, 2, 7, 8 are on the outside. So since 1 and 7 are both on the outside and across the transversal from each other, they are congruent. Since 2 and 8 are both on the outside and across from the transversal from each other, they are congruent. We can prove this in the same way as we proved the alternate interior angle theorem. We know that 1 and 5 are corresponding. We know that 5 and 7 are vertical. Therefore, since 5 is congruent to 1 and 5 is congruent to 7, 1 has to be congruent to 7. Same thing is true with 2 and 8. 2 and 4 are vertical, 4 and 8 are corresponding. Therefore, 2 is congruent to 8. The last theorem is the same side interior angle theorem. So once again, we have interior, which means we're looking at the angles that are inside the parallel lines. And same side means that they're the angles that are not on opposite sides of the transversal. So 4 and 5 are on the same side of the transversal, and so are 3 and 6. What this theorem tells us is that if two angles are on the same side of the transversal, and they're both on the inside, then they're supplementary. So since the lines are parallel, intersected by the transversal, and 3 and 6 are on the same side of the transversal and on the inside, then they are supplementary. So 3 and 6 add up to 180, and so do 4 and 5. And we can prove it in the same manner that we proved the alternate interior and alternate exterior angle theorem. So let's talk about 3 and 6. 3 and 7 are vertical angles. 1 and 5 are corresponding, right? 5 and 6 form a linear pair. So that means that if 5 plus 6 adds up to 180, that means that 6 plus 5 equals 180. 5 and 1 are congruent, so 6 plus 1 add up to 180. 1 and 3 are congruent, so 6 and 3 add up to 180. You could do a little quicker proof using the alternate interior angle theorem as well. We'll use that over here. So 2 and 4 are congruent. 4 and 6 are congruent. 6 and 5 are a linear pair, so 6 plus 5 up to 180. 6 and 4 are congruent by the alternate interior angle theorem, which means that if 6 plus 5 adds up to 180, then 4 plus 5 adds up to 180. So that is just a kind of quick proof of the same side interior angle theorem as well. Now you may have noticed at the top of each of these slides we have like SSI. That is a shorthand for the same side interior angle theorem. The same is true for the The same is true for the alternate exterior angle theorem. AEA is the shorthand, and AIA is the shorthand for the alternate interior angle theorem. Sorry I didn't point that out as we went through it. The corresponding angles postulate does not have a shorthand. You have to write that one all out. So let's apply these theorems. Example 1. If measure angle 4 is 110, what do all the other angles measure? Well, if I look at angle 4 and I only consider this top intersection, I can figure out the measures of angles 1, 2, and 3 without anything that I learned new today. I know that 2 and 4 are vertical angles. I know that 1 and 4 are a linear pair. I know that 4 and 3 are a linear pair. So right away we can figure out what each of those are. So 2 and 4 are both 110, and then 180 minus 110 is 70, so 1 and 3 are both 70. And how do we know that? Well, we know that by 1 and 4 are a linear pair, so they have to 180. 2 and 4 are vertical angles. 3 and 4 are linear pairs, so they have to 180. So I didn't have to apply anything new. And typically, as long as you stay on one intersection, so this is the same intersection, as long as I stay on this intersection, I don't need any of the new theorems or postulates. But the new scenario today is if two lines are parallel. So in order to extend our understanding to this intersection down here, we have to use our new theorems and postulates that we just learned. So what angles down there are 110? What angles at this bottom intersection are 70? Well, if angle 4 is 110, then we can use the alternate interior angle theorem to show that angle 6 is 110. If angle 4 is 110, we can use the same side interior angle to show that angle 5 is 70. We know 1 is 70. Which angle, we know 1 is 70. Which angle is alternate exterior? 7. So that's got to be 70. We know 2 is 110. Which one's the alternate exterior? 8. So that's got to be 110. So 5 is 70, 6 is 110, 7 is 70, 8 is 110. How we know that can be different though. I went through alternate exteriors, alternate interiors, and same side interiors to find that. But over here, we talk about how 6 is the alternate interior angle with 4, so they're both 110. We also could have said 6 and 2 are corresponding, so they're both 110, right? 7 is 70 because it's alternate exterior with 1. We could also say 7, angle 7 is 70 because it's corresponding with 3. I mean, there are multiple ways to do this how do you know over here. So it all depends on which theorem you want to apply. I typically apply the alternate interior and alternate exterior whenever possible because for whatever reason, those are the ones that I think are the easiest to apply. Right, moving on to the next slide. Example 2. If measure angle 7 is 55, what do all the other angles measure? I don't know why there's an angle 1 in there. If measure angle 1 is 55, what do all the other angles measure? Just ignore that angle 1 at that. Wow. Doesn't matter how many times you proofread something, I guess. So, angle 1 is 55 degrees. Find the measure of all the other angles. You don't need to justify it yet. I just want you to find the measure. So I'll give you a few moments here to do that on your own. Okay, so if we had enough time to find all the angles. So here's the measures of all the angles. 7 is 55, and so is 5, so is 3, and so is 1. Those are all 55. If 8 is 125, then so is 6, and so is 4, and so is 2. So how do we know this? So if those are all the measures, how do we know which angles are which? How do we know which angles are congruent? How do we know which angles are supplementary? So take a moment, and I want you to fill in this column over here. How do we know the measure of each angle? Okay, so hopefully enough time there. So here's how we know. We know 7 is 55. 1 and 5 are alternate exterior, so they're both 55 degrees. 1 and 2 make a linear pair. 180 minus 55 is 125. 3 and 7 are corresponding, so they're both 55. 4 is a linear pair with 3, and it's also a linear pair with 1, so 4 is going to be 125. 5 is same side interior with 4, so they got to have to 180, so it's got to be 55. 6 is alternate interior with 4, so it's 125. And 8 is a linear pair of 7, so it's 125. There are multiple ways that we could justify all of these angles. For example, we jumped right to 1 and kind of worked our way around up here and then came back down. I could say 5 and 7 are vertical angles, so 5 is 55. And then say 5 and 3 are alternate interior, so 3 is 55. And then say 3 and 1 are vertical angles, so they're 55. There are any number of ways you can apply these theorems. Similarly, I could say, well, if 7 is 55, then I know 8 is 125 because they're a linear pair. then 8 and 2 are alternate exterior, so 2's got to be 125. 2 and 6 are corresponding, so they both got to be 125. And 2 and 4 are vertical, so they both got to be 125. So there are lots of ways to fill in this column over here on the right. Next example. This is going one step deeper into the difficulty level. All right. So once again, we have two parallel lines. So these two yellow lines are parallel, and they're cut by this green line. That green line is the transversal. So find the value of x if the two yellow lines are parallel. So what that means is I want to find the value of x that makes these angles satisfy one of the theorems. So I need to figure out what kind of angles these are. So 4x plus 5 and 12x plus 15 are both on the inside of the parallel lines, and they're on the same side of the transversal. So I have options. I can use the vertical angle theorem. I could use the linear definition of linear pair, corresponding angles postulate, alternate interior angle theorem, alternate exterior angle theorem, same side interior angle postulate. All right, theorem, not postulate. So I gotta apply the one that's appropriate. So take a moment and think about which one you think we should apply. So the angles here are same side interior. So since they're same side interior, we know that 12x plus 15 adds up to 4x plus 5, and they equal 180 because that's the same side interior angle theorem. So 12x plus 15 plus 4x plus 5 equals 180. So in order to figure out the value of x, I need to solve this expression for x. First step is combine like terms. 12x and 4x both have x's. Those are like terms. 15 and 5 don't. Those are like terms. So combining like terms yields 16x plus 20 equals 180. Next step is to subtract 20 from both sides. So 16x plus 20 equals 180. I'm going to subtract 20 from both sides, and we end up with 16x equals 60, or 160, sorry. The next step is to getting the x by itself is to divide by 16. Dividing both sides by 16 yields x equals 10. So now this is the value of x that makes the two lines parallel. To check ourselves, we could actually plug in 10 in for x into both these expressions. So 4 times 10 makes 40 plus 5 makes 45. 12 times 10 makes 120 plus 15 makes 135. 135 plus 45 makes 180. Voila, 12x plus 15 plus 4x plus 5 equals 180. They're supplementary. Example 4. Find the value of x if the two lines are parallel. So once again, we have two parallel lines, the yellow lines intersected by the green line. The green line is a transversal. Now we want to figure out the value of x that makes these lines parallel. So take a moment here and try to identify what kind of angles we have so that we can solve for x. So these angles right here are alternate interior angles. They're both inside the parallel lines and on opposite sides of the transversal. So from our alternate interior angle theorem, we know these angles are congruent. So 8x minus 12 equals 4x plus 10. They are alternate interior angles, so they are congruent. So now I need to solve this expression for x to find the value of x that makes the two statements true. Or the two statements equal. So the first step here is to get all the x's to one side and get all the numbers to the other side. So I'm going to do that by subtracting 4x from both sides. So 8x minus 4x is 4x. 4x minus 4x is 0. So we get 4x minus 12 equals 10. The next step is to add 12 to both sides. So we get 4x equals 22. The last step in this process is to solve for x by dividing by 4. And we end up with x equals 5.5. Once again, we can plug in our values for x to make sure that these angles are in fact equal. So 4 times 5.5 equals 22. 22 plus 10 equals 32. 8 times 5.5 equals 44. 44 minus 12 is 32. So both angles are 32, which shows that those two angles are in fact equal. I hope this is a good example of teacher-centered. Well, I know this was a good example of a teacher-centered lesson. Thank you for your time.
Right on.
Blah, blah, blah.